Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we are going to talk about identity and access management policies in AWS Cloud. Let's talk about IAM policy types. The first one is identity-based policies. Managed and inline policies to IAM identities. These policies are attached to users, user groups, and roles. This is primarily saying all these IAM identities will either have a managed policy, an inline, or a custom policy. The next one is resource-based policies. These are inline policies to resources such as S3, SQS, and many more services. Services that accept a resource-based policy has its own benefits and requirements. We'll talk about resource-based policy in the following slides. Permission boundaries. Permission boundaries are primarily setting up the maximum permission for an IAM entity within AWS, which means given a role, a user when he logs in, an entity when it logs in, then the permission boundary can still reduce its overall permissions, and we'll talk about those in the following slides. Organizations SCPs or service control policies. This is more of setting permission guardrail across AWS organizations, which means if an organization has multiple accounts attached to it, in those cases, these accounts will have guardrails defined by the root account or the managing account. ACLs or access control lists. These are used for controlling access to S3 buckets and objects within those S3 buckets. Session policies. These are primarily focused on granting temporary permissions for an IAM session using the AWS STS. Let's look into the next slide. This slide is talking about how we should be reading an AWS IAM policy and what all things are required in an IAM policy. So this is a small JSON I have picked from AWS examples. And you can see version statement, which is an array. And then you have each statement, which is starting from this to this, is one of the grant, which can be allow or deny. In this case, the SID is optional. You can just put whatever you want. EAR, if you remember, it should be effect, action, and resource. These are the three things that are required in a policy. So you can see the effect in this case is allow, and the action that you can take is S3, which is the service name, and then the action within S3, get bucket location, get account public access block, list access points, list all my buckets. These are the actions that can be performed by applying this policy, any identity or any other service role. The resource over here is saying that all the S3 buckets, this is an ARN with a asterisk at the end or star at the end, which means all the S3 buckets. Let's look at the next slide. Now, if it is an identity-based policy, this is an example, same JSON file. The only thing I am focusing here is to show you the values that are required. So in the previous slide, we looked at what or how do we read a policy document. In this slide, we are looking at what values make sense. So the effect can be allow or deny. And if it is a deny, users will not be able to do certain action. This is allow action, which means these four actions will be allowed to whoever has this policy applied, and all the resources within S3, this policy will be applicable. Now this policy is here, but how are we going to use it? As I already mentioned, this is an identity-based policy, and identities are user groups, and roles. So in this case, let's assume this policy is assigned to a user named Brian. Now when Brian logs in, he should be able to allow to perform these actions on S3 bucket. It is attached to either a role or a user group. Let's look at the next policy document, which is resource-based policies. Now, there is a difference between an identity-based policy versus resource-based policy. Suppose you have an S3 bucket and you want all the users in your organization who have only admin access should be able to access that particular S3 bucket. That can be achieved more easily by having a resource-based policy that can have, say, I want to have a user who the principal can be user slash, in this case, you have Brian. You can do it the other way, saying, I want users to have certain tags, such as they are from the group of administrators. And if the tag is present, I will allow them to upload a document. In this case, the thing that I'm highlighting is a principal, and you're looking at ARN of a principal saying the user is Brian, and Brian is allowed to perform action on static website as well as the objects. This slash asterisk or star is telling that he can not only perform this action on resource static website, but all the objects within the static website S3 bucket. And what actions the user can perform? He can perform all the S3 service actions. This asterisk over here or star over here denotes that all the actions within the S3 bucket can be performed. So anything that you can see in the API of S3 is available for this particular user. That's what it is written. The policy specifies that only Brian user can access the S3 bucket static website and its objects. In a nutshell, that's what we call a resource-based policy. Permission boundaries. Now, what is permission boundaries? I have a screenshot for you and some text over here, but let's talk about permission boundaries. So suppose I am a user and I have these policies attached to me. I have SSM full access, EC2 role for SSM, and few more AWS managed as well as some customer managed policies. Now, if a permission boundary is set, which is basically an aggregation, and you see the intersection of this data, the overall policy that will be applied will be based on what is allowed within the permission boundary. Suppose I have these 3 AWS managed policies, but my permission boundary is restricting me to just use one of them. That will be the max I could use, which means permission boundary serve to control the maximum permission an IAM entity can have. They act as an additional layer of control beyond the permission policies attached directly to the entity, which means I have 5 policies attached to this user. And if there is a permission boundary that is restricting only one of them to be used, that is the max this user can use. That's how you define the permission boundary. What is a service control policy or policies over here? You can say SCP or organizational policies used to manage permission across an AWS organization. Why do we need it? It provides a centralized control over max permissions for all accounts within the organization. SCPs ensure adherence to access control guidelines set by the organization. SCP requires all AWS organization features to be enabled. There are 2 ways you can enable AWS organization. One is by just enabling the billing, and the second one is by enabling the all feature set of AWS organization. SCPs will not be available if you are just enabling it for billing. If you're enabling it for full feature set, in that case, SCP will be available. While SCP sets limits on actions, they do not grant permissions themselves. And this is important to understand. SCP will say these are the allow list, or these are the services that are allowed within the organization, or these are the service I can start with the allow list, or I can start with the deny list. If I start with the allow list, I would just say these are the allowed ones, or I can give everything to everyone and then start adding deny list, which will remove all these services that are consumed by accounts in case I put them in deny list. So suppose I say S3 is allowed to everyone, but AppStream is not allowed to everyone. So in that case, no one within the AWS organization will be allowed to use AppStream. Now, this is saying grants or permissions, as it is mentioned here. It only allows or denies a service, but it doesn't allow any grants or permissions. So administrators for various identity-based or resource-based policy have to give this role-based or user-based permissions. The effective permissions Effective permission is basically taking what you get from SCP and what you get from the IAM or the resource policy and what is the intersection of that particular set of policies that gives you the effective permission. ACLs, access control lists. ACLs are used to control access to AWS resources, and in particular, we are using it for S3 buckets and objects. They allow you to specify which AWS accounts or predefined group of users have access to the resources and the type of access they have. ACLs are managed directly within the AWS management console or through API calls. So using the SDK, we can still make a call for ACL. They provide a simple yet powerful way to manage access to resources at a high level. ACLs can grant permission such as read, write, full control, allowing for granular control over resource access. Let's look into ACL permissions. This is a picture from AWS website. You have permissions such as read, write, read underscore ACP, write underscore ACP, ACP, which is access control policies, and then you have full underscore control. These are the various permissions that you can grant on a bucket or you can grant on an object, depending upon what you are focusing on. If it is a write, it is at a bucket level. If it is a read, it is getting the list of the buckets as well as the data and metadata of objects within that bucket. Read ACP, it allows you to read the bucket ACL. And if you apply at the object, it will allow you to read the object ACL. We'll look into some details around this, but there is a link from where I have picked this, and this is from Amazon website itself. Write allows you to write the ACL for a specific bucket, or it allows you to grant the write for that particular bucket. Similarly, it can allow you to set the ACL for an object within the bucket. Full control allows you to give all four of them over here at a bucket or an object level. This is all coming from AWS website directly, and I have added the link below for your reference. What's a policy evaluation logic? So let's look into the logic over here. This is a flowchart from AWS website itself. You can see implicitly everything is denied. Create a user and you are not assigning anything to the user. And if user or that identity wants to access any of the resources or service, it will be an implicit deny. If all the policies are evaluated and if there is an explicit deny, then the decision is still a deny. If there is no explicit deny, we look at the permissions over here. What is, if it is an identity-based policy, if there is a resource-based policy, then if there is an allow, only then there is an allow. Else, it is still deny. The source of this picture is given below. You can always visit the AWS website and find the details. Let's look into the policy evaluation logic. We are looking at the identity-based policy with resource-based policies. So you can see if a user has an identity-based policy and there is a resource that also has a policy applied to this. This is the total set of permission, which is an aggregation of overall permission provided to the identity as well as the resource that will be applied for evaluating whether an allow or an explicit deny is required. An implicit deny can be overridden by an explicit allow. An explicit deny will always override any allow, which means implicitly if you have a deny, you can override that with an allow. But if you have an explicit deny, then all the allows will be overridden by the explicit deny. And the reason is implicit deny is when you create a user and nothing is assigned to the user, that's an implicit deny. Once you start assigning that user, that is an explicit allow. But if there is a deny at a resource level or an identity level, in those cases, that will take precedence. We are evaluating identity-based policies with organizations' SCPs or service control policies. So in case a user is a part of an account that is a member of an organization, the resulting policy that is applied, whether it is a user policy, if he has some set of policies, and there is an SCP, it's basically an intersection of those. So user will get the effective permission, which is an intersection between the organization's SCP and the identity-based policies. Okay, let's talk about IAM in lab now. So first of all, if you are in this console, I have logged into my root user console and I can search for IAM and open that in a new tab. You can see certain things such as user groups, users, roles, policies, identity providers. This is for an external or a different identity provider if you want to use. Let's look into the user group. I have opened all of them in separate tabs. Before going to user group, let's talk about users. In this case, you can see if you click on the users on the left menu, you can see there is a user over here. There are two users basically, but you can see there is a no access user and this user can be created. I can show you how to create a user. You can just define a name. You can say demo. Let me make it smaller, demo user. And then you can provide AWS console access, or it can be just a programmatic access. And I will not give that. And you can add a user to a group. Now, what is a group? Basically, let me add it to a QA group and then say, over here, you can provide additional tags. I will leave the tags for now, right now, and create a user. So you have this demo user, and this demo user is not having any access. What you can do is you can go to the QA group where there is already a no access user, and you can assign a permission at a group level, or you can come back and assign a permission at a user level. In our case, I'm doing it at a user level so that I can demonstrate just a single user. But as a rule of thumb, if you need to create users, it's a better way to do is that you create a user group like developers in QA in this case, and just manage the permissions at the group level. So if you add or remove a user from a group, they will receive or the permissions will be revoked as soon as they're out of the groups. So that is the reason of having a user group, that you don't have to micromanage each and every user on a daily basis. You just have to manage the groups and who is part of that group. Let's talk about roles, which is the third from the top in the access management. Over here, you can see 4 roles defined, and it is giving you trusted entities that these roles are associated with. To create a role, you could just go here and select one of the entity type. It can be an AWS service, it can be an AWS account, a different web identity. You can have a SAML, you can have a trusted policy. And if you choose one of the service, I am choosing EC2. There are other options or use cases. You can just select the set of permission. And these are the managed policies. If I say EC2 full access, which means if you expand this, you can see what all things this role will be allowed to do. EC2 allow all resources, ELB all resources, CloudWatch all resources, auto scaling all resources, and other things. If I say next, you can give a name, my custom role, and you can see there is a STS assume role. We'll talk about these in a separate video, but this is more about a service, in this case EC2 service, taking or assuming this role to perform some certain actions on your behalf. So on the role, you can just create a role. This is a custom role, and this is basically other roles that were provided. Now let's talk about policies. They are fourth in the access management. If you click on the policies, you will get a list of policies. You can see I have 1,000+ policies, but most of them are AWS managed. If you look at the dropdown, there are customer managed, there are AWS managed related to a job function, or AWS managed. So if I search for this, you can see these are related to a job function like a system administrator, a support role, a security auditor, read-only access. You can create your own policies. And if you look at the custom managed, I just created one of them. This was a customer managed. Creating a policy is again simple. You can choose a service. Let me choose EC2 as a service, and I will just say, for simplicity, all actions, and I'll just say all resources. Let me select all resources, all actions, and then you can give a name, my EC2 policy. This is telling you that you have access to EC2, full access, all resources. If you want to add tags, you can add it. You can create a policy. Now, if you look at your customer managed, you will see another policy here. So that's how you create a policy. I also wanted to show you, let me switch back to all types. And if you search for deny, you can see there is a deny policy. And if you expand, you can see that effect is deny and all actions in all resources. That's a AWS managed policy that is already available. But in your policies, you can have several statements like these. You can have a allow statement. You can have a deny statement. Remember, implicit deny can be overridden by explicit allow. But if there is an explicitly defined deny, then that wins. Deny will override any kind of allow. Now let's talk about the AWS organization. Let me switch back to the console. This is the dashboard. And if you look at the AWS organization, which is the second tab from the left, how do you enable organization? Basically, if you are logged in as a root user, you can enable organization in your account. And while enabling an organization, you'll have two options. You can just enable it for billing, or you can enable all the features. So what I did was I enabled all the features a couple of months back. And what I did was, you can see there is a root that has been created here, and there is a account. This is the management account that I'm logged in with. Then you have a developer account that I created. This is just for demonstration. And the reason this organization was created was that I wanted to show you how various organizational units or OUs, they are attached, and what is the implication of having a service policy. Now in this case, if a service policy is applied at this level, root level, basically the management account will set the service policy, and all the OUs, basically in this case, you can see dev is an OU. If I click on the dev, it's an organizational unit. And this org unit has a child AWS account. Now in this case, we can apply several policies, which are called service control policies, which means at the root level or at any level, if you look at the top level, if you see the root level, the policies that are provided by the root is full AWS access. Means there are two ways to apply policies. One is you can just say allow using the allow list or the deny list. In our case, we are saying we are allowing everything to be used. So there is a full access. Now, the children of this particular root, in this case, suppose admin, and admin is getting directly attached this full access while it is also inheriting from the root. But what can happen is you can have a separate policy for your OU. In this case, suppose this is an dev OU or this one is an admin OU. If you're attaching a policy directly to your OU, denying some of the services that your OU can use, or the organizational unit can use, then in that case, even if it is allowed at the root level, the override will happen over here and you will not be allowed to access that particular service. An example of that will be the root is allowing you to utilize EC2 instance, but when you go to dev, there is a policy that says deny EC2 instance, the service altogether, deny usage of EC2 service. In that case, no one in this particular OU, no account in this particular OU will be able to use the EC2 service. Let me show you some other things, such as how you invite a user, in this case, how you invite an account to add to a AWS organization. So if you click on invitations, you can create an invitation. So you can invite, giving an account ID and sending the invitation. Once the invitation has been accepted, this is for an existing AWS account. Once it is the invitation is sent and they accept it, in that case, that account will start showing up in the organization. Now, if you want to add a new account, you can simply go and create a new account under this OU. This is going to be the root, I guess, when you create it, but you can move around. So that's how you send invitations, two ways: create a new account or add an existing one. And an existing account, if it is part of a different organization, that will have to first detach from that organization in order to attach to this particular organization. You cannot be part of two organizations at the same time. So one AWS organizations, in this case, if an account is added to this organization, that is the only organization that account belongs to. Let's look at the services. These are the services, some integrated services around access and permissions, compliance and audit, resource management, and security. So currently it is disabled. Most of them are disabled. You can see guard duty, inspector, detective, and a lot more services. But I have just enabled the AWS IAM Identity Center, the AWS single sign-on. This was enabled. Now, if you look at the settings, I don't have anything specific over here. If you look at the policies, I wanted to show you policies. So things that I have enabled for this particular organization, they are service control policies and tagging policies. So you can enable tagging, must-have tagging for each resource within your organization. This is kind of a compliance. If you enable tagging and there are resources that are not following your tagging policy, in that case, those can be flagged, and you can even terminate EC2 instances if the tagging policies are not adhered to. So kind of a good control. Service control policies, the two ways: either you give all the services or you just give services that you don't want anyone to use. So two ways to handle this. In our case, it is AWS full access. And if you can see, the policy is pretty small. It is just saying allow, action, resource, everything is allowed. All actions, all resources. Let's look at the difference between the IAM user over here. You can see identity and access management users versus a user that is under IAM Identity Center. There is another users. What's the difference? So the difference over here is we have enabled Identity Center, which is like an org level capability. And this is like managing users across multiple AWS accounts in cloud applications. Now, if you look at the statement over here, it is saying that it provides identity long-term credentials but it is with an account, with a given AWS account. So this user, no access user, is only for this particular account, and it cannot use or cannot be assigned to a separate account. While in case of this user, which is a IAM identity user, identity center user, this user, Justin, is assigned to a set of, you can see, across multiple accounts and cloud applications. So that's the basic difference. Now, if you are creating a IAM user and you have an org available, in that case, the recommendation that AWS is providing, it will give you some small notification saying the recommended approach is to create a user in IAM Identity Center. First of all, there are rare cases where you actually create users. Most of the users that we have created in our system, they're kind of an application or a system user, while rest of the stuff runs under a role. So if you assign a role, if you assume a role, the recommendation is to rely on roles rather than a logged in user. Okay, let's look at the capabilities using the policies that identity-based policy will give you in case we have an IAM user. Now in this case, I have this no access user. Let me open this in a new tab. The no access user, you can see the set of permissions is all empty. User doesn't have any permission, which means user is allowed to log in. But what will happen once he logs in? I have opened this user in a separate browser. Let's see. I have in Safari. Okay. So you can see this user is no access user over here. This one. And as soon as I log in, you can see certain things are access denied. But let's see, can I go to S3? Can I go to an S3 dashboard? See the buckets. Let me make it bigger. So you can see that I don't have any permissions to even have a list of buckets. Let me go back and add a permission to this particular user. So I'll add a permission, and rather than attaching it to a group, I'll just attach a policy here. Let me give this user a S3 full access. And add the permission. As soon as you are done with this, if you refresh the other user, you can see that error has gone, and you can see that you have the capability now to create a bucket. So if I create a bucket, I'll just create a sample bucket. No access user sample bucket. I'll just keep everything same. And you can see that I am able to create a bucket. Now this behavior, what does that shows us? If you look back, when we were having no policies attached, and this user was just created, it was implicitly denied to have any access. You could log in, but there was nothing you could do. Once I added a policy such as S3 full access. Now the user is able to perform certain actions. In this case, you can see that user was able to perform a creation of a bucket. User can even upload. Let me give you a demo of upload. So if I upload this file, you can see that this no access user is able to upload the file. Let me close this. This file was uploaded. This PNG is now uploaded by this particular user. So it proves the point that implicitly everything was denied. Once you override this implicit deny by attaching a policy to this user, the user is able to perform the action. So a explicit assignment is removing the implicit deny. Okay, let's change this policy a little bit. Let me remove full access from AWS S3 and say admin. Sorry, I need to add a permission. I'll attach a policy admin. I'll give an admin access, which means if you look at the policy, everything is allowed, all the actions, all the resources. So this user can perform everything, and I'll attach this permission. Now this user, no access user, has a policy, which is an admin policy, but I'm gonna set a permission boundary. And if you remember, what is a permission boundary is that whatever access you gave, I gave a full access, but I can reduce that full access by applying a permission boundary on top of it. So if I say just EC2, I'll just say S3 full access again. In this case, I'll just give S3 full access. And you can see the boundary has been set on this user. And if I go back to this window, I can create another bucket. No access user, another bucket. And let me make it bigger. So this was no access user, another bucket that I'm going to create. This user was able to create another bucket. Now let's go to EC2. And it is trying to see how many EC2 instances are running. As soon as you are on dashboard, you can see there are API errors that are coming. All this information is getting an exception. The reason is your permission boundary is restricting user from even looking at the running instances. Or even we can try, it is giving an error itself over here. So you can see that no access user is not authorized to perform describe instances because no permission boundary allows this action. Which means if you look back to this user, even though you have an admin access, but we have reduced your admin access to only these two things. So that's how permission boundary works. Okay, let's look into the resource-based policy. So let's go to an S3 bucket. Let me refresh. We created these two S3 buckets, right, using the no access user, but I am logged in as the root user. Let me go and go to this bucket. You can see there is already a file that was uploaded by no access user. And if I go to, let's go to the permissions, and you can see a bucket policy. As I mentioned, there are bucket policies that allow you to restrict or allow or deny a certain user, certain principal on a bucket, and you can safeguard your bucket given the amount of trust you want to open this bucket with, or you want to safeguard your bucket saying I want that every upload in this bucket should be encrypted. So there is no bucket policy over here. Let me try and add a bucket policy. I will edit this and I will add a policy which is here. Okay, let me explain this. Okay, let me fix this. Now, this is a bucket policy that is saying deny all the principal, including any logged in user right now in this particular account, where the bucket name is, I'll just pick the bucket name. The ARN is here. I can just copy the ARN and paste it over here. Remember to have this / in asterisk, which is saying that all the objects within this bucket, we are saying in case anything that is uploaded, if it is not having a KMS key ID, then don't allow it to be uploaded. So that's a bucket policy. If I change this, and if I go back to this object tab, let me try to upload another file. And I'm saying upload this to this particular bucket. And you can see that the upload failed. And the reason upload failed was that access was denied, as this file is not an encrypted file. So even as a root user who has all the permissions in this particular account, this policy is, the resource policy is not allowing any unencrypted data to be uploaded. So any object that is in this particular bucket going forward, because this was already uploaded before the policy was applied, but anything that you want to upload on this bucket should be encrypted. Now, what is the benefit of having this resource policy? This is beneficial in case, suppose you have 10 users or you have 10 roles applied and used by several services, and each of those roles are defining that every upload to the bucket, this bucket, should have an encryption. First of all, you are going to have a lot more places to modify and add this check. Secondly, if an admin user is there or a root user in this case, the root user can still override. He can just upload any kind of file and that will go unchecked. So in certain cases, it is advisable that you modify at the resource level so that the resource itself takes care of whatever the business requirement is. In this case, we were trying to restrict any kind of files that are uploaded and that are not encrypted in this particular S3 bucket. The best way to do is to allow the bucket to handle its own policies. This policy can even be modified to allow from different principals, which can be an external account that is allowed to upload in this bucket. So you can have multiple statements over here saying principal X is allowed to upload from account, whatever the account is, because that will have the user / whatever information for that particular principal into this particular bucket. So that's the beauty and the magic of having a resource-based policy. Let me show you additional thing around AWS organization. So I am on the dashboard of IAM Identity Center. And you can see that I created a AWS Access Portal. This was just created for allowing a single sign-on. And you can look at the users that we have. I have this one user, Justin user, that is attached to one account over here. And you can see the access he is getting. So he's an admin in this particular account. And you can look at the groups. I didn't create a group. AWS accounts. You can see 2 AWS accounts that I already showed you. Then the permission sets. I have created one permission set, and this is basically an admin access. And this admin access is to this account. And if I click on that, you can see the user and groups that are assigned to this particular account. You can see Justin is assigned with an admin access. And similarly, the permission set is defined here. You can have several permission sets. Right now, no policies are attached over here. So what will happen if Justin log in? It is going to be the same experience. Let me show you. So I am at this particular, let me refresh this. When Justin logs in, because he's attached to one account, this is a single sign-on page. Once Justin logs in, he can see one account here. If there are 5 accounts, he will see 5 different accounts. Because Justin is allowed to do a programmatic access or a command line access, he can use this to generate access and secret key. Similarly, the management console, if you click on this, it will open in a new window. Justin is logged in, but you can see because Justin, that admin access doesn't have any privileges or any policies attached, Justin cannot do anything over here. So let me open S3, and if I show you buckets, you can see you don't have any permissions. So if I go back over here, if I attach a policy, say admin access, attach a policy, and if I refresh this, it takes some time. Now you have access. So that's all, whether it is a single account or it is a single sign-on account, because this is a different account. This is a 8118 account, while the root account is 2037. So it's a different account within the same org. That's how, whether it is a single account or multiple account, all these identity-based policies which are applied to users, user groups, or you can say IAM groups, and roles. So all these users, whether it is a identity center user or you can see the regular IAM users, roles, policies. So you have identity policies attached to roles, users, and user groups. Hope that helps. This is the end of the episode. Thank you for watching. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.